Today we are going to be working on a combined spectral problem for week 15, group 13. So I got C10, H12, O. I'm going to calculate my degree of unsaturation. I'm going to do that by taking my carbons. Number of carbons I have multiplied by 2. Add 2 and subtract by the number of hydrogens I have, which is 12. So it's going to be 20 plus 2, 22 minus 12. It's be 10 over 2. Divide the whole thing by 2, and you're going to get 5. So my degree of unsaturation is 5. That is going to be a pretty high number. So it's going to tell me that I have an aromatic ring. And that's also going to tell me that I have a double bond somewhere located in this. So now I'm going to go down to my IR spectrum, and I'm going to break it up just so I can easily see 3,000 and 1,500. I'll also do it again at 1,000. Because after everything below 1,000, I'm not too concerned about for this course, but this will help me help me distinguish what peaks to look at. So first, probably at around a frequency of 2,900 in this 3,000 era. That is going to tell me that I got my sp3 bonds. And then here at around 1,700, I know that's going to be my carbon double bond. So I know that. So that checks out with that double bond. And then here, I'm going to break that. I know I got two groups of peaks here that are very distinguishable. So I know around this area, that's going to be my carbon double bond. So around 1,400-ish. That's going to be my carbon double bonds, and everything below that. 1,200, 1,250 area right here, this peak. That's going to be my carbon single bonds. So I know that. So I can move on here. So I got my sp3 bonds, my carbon double bond with an oxygen, carbon double bonds, my sp2s, and then an sp. So, okay, and now on to my 13C graph. I'm going to be concerned with each peak here because that's going to be a noticeable, I'd say, a type of bonding environment for those carbons. So first I'm going to be up here. So in like the 200 plus area, that's just an easy give me. And then here, I got a bunch of carbons here, knowing that I have an aromatic ring because my degree of unsaturation. That area around 130 is going to be my aromatic ring with all of those peaks. And then below 100, I got 3 more peaks here, so I got 3 more carbons. And those are all going to be my either carbon, like CH2s or CH3s, those sp3 bonds, just single bonded to each other. So, at 50, I'm going to have a CH2. Oops, erase that. 50 on a CH2. That sp3. 38, and have another CH2, sp3, and then down at 10, I'm going to have that CH3, which is just going to be an sp3 bond. So that helps. And then this next graph will tell me how my proton's reacting and also kind of tell me where each carbon is going to go. So here I got a 1H, my proton graph. showing me kind of where my protons are acting and how many protons are neighboring each other here. So 5H, so 7 point roughly 3. You know, I have an integration of 5H and then a multiplicity, and it's a singlet. So a singlet is just going to be n minus 1. So I got 1 minus 1 equals 0. So it's going to have 0 neighboring protons. So singlet, 0 neighboring protons. And I know that 5H is going to describe to me that aromatic ring, because I know one of those carbons are going to be attached to a carbon, and then there's going to be 5 hydrogens attached to the aromatic ring. So that's great. At 3.6, I'm going to have 2H. So it's going to be that CH2 that I kind of brought up back here, either one of these. And then that is also another singlet. So that is going to tell me there's 0 proton neighboring. So yeah, so I got that CH2, and I can assume that's going to be attached to that aromatic ring. And then it's also going to be attached to that carbon double bond I don't want to forget about, that I know that's attached because of this 200, and then the 1700 is telling me that I have that carbon double bond to an oxygen, that carbonyl group. So yay for that right there. And then at 2.5, I'm going to have 2H again, so another CH2. That is going to be a quartet. So now I'm going to have 3 protons, 3 neighboring protons. So CH2, let me attach it to CH3. 3 neighboring protons. And then at 1, you have a 3H, which is a triplet because it has three different peaks. That is going to be roughly, that is going to be 2 neighboring protons. So just taking that 2.5 and then a CH3, attach that CH2. So here I can completely give you my final answer, which is just going to be that aromatic ring with all those double bonds that I know that are in there, attached to that carbon that has a CH2, attached to that carbon, double bonded to oxygen, attached to that CH, oopsies, carbon, attached to that CH2, and then a CH3. Not an actual 3. CH3. And then if I wanted to double check, I would know this CH3 has 2 neighboring protons right here and right here. And then this carbon has 3 neighboring protons right here. So that checks out. This one checks out. And then I know this singlet at 3.6 right here has 0 neighboring hydrogens, but it has 2 hydrogens attached. So that checks out. And then at 7.3, you just have the aromatic ring with 0 neighboring protons. So that is it. Thank you.